Hello everyone, welcome. Today I'm going to talk about the power function. The power function calculates x raised to the power of n, and you might think this question is very simple, since you can just use a brute force solution to calculate x, the base x times itself n times, and then you get an answer. However, when n is very large, basically you are iterating over a very long list, and the time complexity will be O(n), will be very slow, such as in this example, 2 to the power of 1 million. It will be very, very slow. So how can we improve on this time complexity here? To solve this question efficiently, we need to know the power rule for exponents, which governs the power of a power. The general form is seen here. X to the power a to the power b equals to x to the power a times b. And you can extend this general form to this form here. X to the power of n equals to x squared to the power of n divided by 2. And also, if your exponent is a negative integer, you can turn it to a positive integer exponent by using this rule here. X to the power of negative n equals to x to the power of negative 1 to the power of n. So these three important properties will help us solve this problem. Now, let's observe how this power rule for exponents can help us to solve the problem. Let's say the question asks you 2 to the power of 100. Instead of have 2 times itself 100 times, you do this square and divide it by 2 in the base and the exponent respectively. So you have 2 squared to the power of 50. And then that equals to 4 squared to the power of 25. Because 25 is an odd number, we take the 4 squared out here to make it 24. And then 24 divided by 2 is 12. So it's equals to 16 times 16 squared to the power of 12. And you can repeat this process so on and so forth until you have the exponent equal to 1 and you end here. It's worth noting that only 6 iterations are involved here, which is approximately log base 2 of 100. So instead of have 100 iterations, which is the time complexity of O(n), we have a time complexity of O log base 2 of n instead. In fact, this method for fast computation of large positive integer powers of a number is known as exponentiation by squaring. You may look up the Wikipedia for more details. In general, our approach is to cut the exponent by half, which greatly reduces the time complexity, while the base is becoming its square form and is quite manageable. With all the background knowledge introduced, it's time to write the code. So first of all, we'll deal with some boundary condition. First of all, when n equal to 0, we know the answer will be 1. And if n is a negative integer, we know we should make it a positive integer first by times it with negative 1. And at the same time, if that's the case, x should be 1 divided by x. And now we are ready to deal with the general case. And we're going to remind ourselves and with an example using 2 to the power 10, which equal to 4 to the power 5, because 5 is an odd number, we take 1 4 out. And previously, there's nothing to take out, so we actually it's 1 times. And so 1 4 out and 16 to the power 2 and 256 to the power 1, and that's it. So as you can notice here, there's a leading coefficient like 1, begin with 1 and then become 4. So we say this leading coefficient should be 1 to begin with. Next, we're going to run a while true loop to handle all different kinds of conditions in an iterative way. So first of all, we'll handle the condition when n is an even number like 10. So if n divided by 2 and the remainder is 0, means it's an even number. In this condition, x will simply be x squared and n divided by 2. Okay. And if not, then it's an odd number here. But an odd number can be 1 or can be greater than 1. So they're different. So if it's greater than 1, we know n will be n minus 1 divided by 2, like this 5 minus 1 divided by 2. And in this condition, we take 1x out. So a becomes a times x, and the x also will be x squared, like this. And if it's 1, then we know this a times x will be our answer. So we simply return a times x. And that's our code for power. And let's test this. So we submit. It's pending. And there's a problem here. So else if. So actually it's just else. Submit. Done. With 12 milliseconds, greater than 95% of online submission is pretty good. All right. So finally, we'll analyze the code for complexity. As we mentioned earlier, the time complexity is O log base 2 of n, and the space complexity, since we use constant space variable here like n, a, and x, they are all constant space variable, so it's really O1. Alright, so that's all for this video. Hope you find this video to be useful. This question really depends on your understanding of the power rule for exponents. Please stay tuned for more videos. Hope to see you next time. Goodbye.